So the first thing is that we must be able to correctly say whether the event of interest is present or absent. That means we should avoid false positive and false negative. So the first thing is you use such a investigation or such a series of investigations which you can call as gold standard protocol, and where the false positive and false negative are assumed to be 0%. Example, histological diagnosis in cancer, or identification of the bacteria and its sensitivity to antibiotics in bacteriological infection. So you can use the gold standard. But if gold standard is costly, difficult, invasive, dangerous, painful, not doable, that means a logistic problem, you can't take the MRI to villages, then you have to use a surrogate. But that surrogate has to be tested against the gold standard. So use surrogate. Now, the testing studies of a surrogate against the gold standard are called as validation studies. So, if the answer is event present, absent, both by the gold standard or the surrogate, then this is the gold standard, yes, no, and this is the surrogate, yes, no. And when the surrogate is positive and the gold standard is positive, it is true positive. When the surrogate is positive and the gold standard is negative, the surrogate has falsely said positive. So this is false positive. If the surrogate is negative and the gold standard is negative, gold standard is positive, then the surrogate is saying falsely negative. Okay, we'll label it red. These two are red. Should not be. And if the surrogate is saying negative and the gold standard saying it is true negative. Now, the positive predictive value, if the surrogate is positive and you don't have the gold standard results, the chances that he does have the disease is true positive upon the P, TP upon P. And if the surrogate is negative, then the chances that he has disease is Fn upon Q, and the chances that he does not have disease is Tn upon Q. And this basic column totals, if you want to say how many in the study population had disease, is gold standard positives all, that is S upon the total numbers in the study, S upon R. So here I like you to remember this, that I have recorded that sensitivity is Tp upon S, specificity Tn upon T. They are column values. The row values are positive predictive value Tp upon P, and negative predictive value for normal is Tn upon Q, and for gold standard positives, that means false negatives, it is Fn upon Q. And the prevalence is S upon T. So now, if you are trying to use this test in a population with a different prevalence of disease, then where the S upon T is not the S upon T, then you report a positive likelihood ratio, which is true positive rate upon false positive rate. That means these two squares, Tp upon S, Fp upon T. And if you are trying to calculate the negative likelihood ratio for a population of different prevalence, then you use the false negative rate upon the true negative rate. That is the negative likelihood ratio. So, chances of gold standard positive, that means disease positive, in a different prevalence population is equal to positive likelihood ratio into prevalence in that population, into S upon T in that population. So this is how you can use the test characteristics, the sensitivity, specificity, positive, negative, predictive value of a test in the study population, in a different population, by using likelihood ratios. Now then, how do you combine multiple tests? For example, if a person is, you pick up a person from the market and say you have tuberculosis, then the chance that you are right is 2%, because 2% is the prevalence of tuberculosis. Now, supposing you find him in the hospital, this is the hospital population, this is the general population, then means that he is diseased. That means this baseline prevalence of disease is higher, and therefore this chance that he has tuberculosis will increase just by the information that he is in the hospital. If he is in the chest ward, then the chance may be much higher. If he has cough for 3 months, it is higher. If he has fever for 3 months, it is higher. If he has hemoptysis, it is higher. And if it has responded to anti-tubercular treatment, it is almost certain. So multiple tests done in series, placed in series, yield a very high value of sensitivity and specificity. And therefore, clinical examination, which gives you these multiple informations, is a very powerful method of diagnosis, much better than single MRI or CT scan. Then you can use the value of tests in parallel, and the specificity would increase in series and sensitivity would increase by parallel tests. So this increases sensitivity and that increases specificity. Now, if the gold standard results are not yes, no, they are numeric. So gold standard and surrogate results, both numeric. For example, you are testing bone marrow density by ultrasound because DEXA cannot go to villages and you are trying to do a community research. Then surrogate values 1, 2, 3, 4 are on the x-axis and gold standard values are on the y-axis, and each dot represents the junction of the value by ultrasound and gold standard, each dot. For each dot, you try to draw a line which is called as the least square line, because this line is closest to all the dots. So the distance of this dot from this line is called as the residual, and this is a positive residual. But this one is a negative residual because the observed value is less than the expected value. So you have observed minus expected, which is equal to the residual, and to take off the plus and minus signs of the residual, because some residuals are plus, some are minus. So to take off the sign, you square the residual and then you sum the residual, and you want the sum to be as less as possible. So if the sum of the residuals is less, that means the least square line is closest to these dots. And this is also called as the trend line, and this is the prediction. This is what you use to convert surrogate readings into gold standard readings. So this is validation of when the gold standard and the surrogate is getting you numeric results. For example, blood sugar. Blood sugar by your finger tip method, and blood sugar by, let us say, the lab. Okay, so this is how you can use surrogate when the gold standard and the surrogate results are numeric. If you want to use a formula instead of this graph, then the gold standard reading 2 will be equal to some value, plus incremental increase in the gold standard on the y-axis as the one moves to 2, which is the beta coefficient, which is this ratio is the beta coefficient. So you multiply the surrogate reading with the beta coefficient, add some constant number to it, and you will get the gold standard reading. This is called as correlation coefficient or regression. Linear regression. Okay. Then third situation is that the gold standard is yes or no, but the bone marrow density reading can be 0 to 1 or 1 to 2 or 2 to 3 or 3 to 4 or 4 to 5 and 5 to 6 or 6 to 7. So you are increasing from below downwards. Here you first draw a line between this and this and calculate. So this table will become true positive, false positive, and all these will become false negative, and all these will become true negatives. And you can calculate sensitivity and specificity at each of these cutoffs one by one. And then you add these sensitivity and specificities and you find out where the sum is maximum. That is the correct cutoff, and you can use that cutoff for validation purposes. See, if the ultrasound bone marrow density is more than 3, then the sensitivity is this and the specificity is this. So this is the method of validation. If one of the surrogate or the gold standard is numeric and the other is continuous. So these are diagnostic tests, correlation tests, validation tests, and you have to do studies to find out the test characteristics. How good is a diagnostic test in saying whether the event of interest is present or absent.